Okay, we're just going to do a few problems to review from what we did last week. So I'm going to kind of quickly go through these. We need to use the properties of logarithms. So this is the log base 8 of c times the cube root of a times b. So there is a lot going on here. There's two different types of multiplication, plus there's a power involved. I'm going to rewrite it. Log of base 8, c times, in parentheses, I'm going to put a times b to the 1/3 power. All right, now we have c times all of this. We can go ahead and expand. So log of base 8 of c, remember multiplication gets expanded to addition, plus, but this right here has this exponent, so the exponent gets moved down in front, so plus 1/3, and then all of that's going to get put in parentheses because this 1/3 is outside of the parentheses of a times b, so we're going to have to put log of base 8 of a. Remember, multiplication gets expanded to addition, so log of base 8 b. And then you could go ahead and do the distributive, and I'm not sure if the answer shows that or not. So that would just be 1/3 log base 8 of a. They might even have, instead of 1/3, they might put this whole thing under 3 under it for divide. Either way is acceptable. Plus 1/3 log of base 8 of b. All right, that's expanded. Let's go ahead and look over here. So now you have the whole thing being squared, so that 2 will have to come out in front of all of it. You have something being divided that will get expanded to subtraction, and then the second one will have an exponent that will have to come down in front. So let's see if I can simplify that. So first off, this 2 has to come here. So 2 times the log, and because that's out in front of everything, I'm going to put a big parentheses like here. Log base 7. And now these two things are divided, so we can use subtraction. So that is x subtract log base 7. And inside there we would have y to the 4th. But this 4 would then, using the properties, would come down to right there. And I think you would have to do the distributive, so that would simplify to log of base 7 of x minus 8, because 2 times -4 is 8, log base 7 y, just like that. Okay, I hope you are following that okay. I'm going to cover that up. I need to see what these next two things are. All right, so we have two things being multiplied, so that means that it can expand to addition. And notice how both of the exponents are on the inside. So we don't have to bring a number out in front of this log initially. So we can just do log of base 2, and that's going to be u to the 4th, plus log base 2 of v to the 4th. Well, now these things get simplified. The 4 will come down in front. The 4 will come down in front. Because those were both to the 4th, we could have done this. We could have put the 4th there and brought it down in front, but that's okay. So we're going to have 4 times the log of base 2 of u plus 4 times the log of base 2 of v. And that's it for that one. All right, let's see what's going on here. Oh, these are those funky ones where they give you a bunch of information and you need to find the properties. So they need you to find log with base 5 of 16, and they give you log base 5 of 7 is equal to 1.2, log with base 5 of 9 is equal to 1.4, and I really should be doing this. That really is a good idea. Log with base 5 of 12 is equal to 1.5. How do those numbers relate? I know exactly how they relate. 12 squared is 144, and 9 times 16 is 144. So, let me think about this right here. If we did this, if we said log with base 5, 12 squared over 9, well, 12 squared is 144, divided by 9 is 16. I want to make sure that's correct. So 12 squared divided by 9, yep, is 16. So now we can go ahead and expand this. We would have 2 times the log of base 5 of 12, subtract log of base 5 of 9. And then we look up here. Oh, the log with base 5 of 12 is 1.5. So 2 times 1.5, which is 3, subtract log base 5 of 9 is 1.4. So subtract 1.4. 3 subtract 1.4. And I'm going to do about, even if that one's exact, about 1.6. Because my guess is these were rounded. All right. Let's go on to the next. Use the properties of logarithms and the logarithms provided to rewrite each logarithm in the terms of the variable given. So this is log of base 7, 7 divided by 144. Well, we could expand that to subtraction. So log of base 7 of 7, subtract log base 7. Well, 144, we have a 12 here, can be rewritten as 12 squared. Then the 2 is going to come down in front. So log of base 7 of 7, subtract 2 times log with base 7 of 12, and then we can do the math. Well, log of base 7 of 7, that cancels to 1. Subtract 2 times, well, the log of base 7 of 12 is v. So your simplified answer is 1 subtract 2v. All right, let's go on to the next one. I know that seems really weird, but that's how you do that. All right, now we have an equation. So let's see what we can do first. Well, we're definitely going to want to get all of this by itself. 9 is attached by multiplication, so I can divide. Well, the 3 and the 9 cancel. 3 is equal to 3 times 1. 9 is the same as 3 times 3. So now we have 16 to the 9 subtract 2r is equal to 1/3. Oh, we're going to have to take the log of both sides. So log, and then what happens? This whole thing comes down in front, so I'm going to give myself some space here. So this 9 subtract 2r, and then times log of 16 is equal to the log of 1/3. Well, we want to get this r by itself, so this log 16 is attached by multiplication. We're going to divide both sides. So 9 subtract 2r is equal to all of this stuff. We want to get this negative 2r by itself, and then eventually the r. Well, how do you cancel a positive 9? Subtract 9. So we're going to subtract 9. Those cancel. The very last step, we're going to divide everything by negative 2. And now you're going to have to be really, really careful, because this is a parentheses. This is a parentheses. You may as well put that in parentheses. So this is what I'm going to type in the calculator. Left parentheses, log 1, fraction button 3, right parentheses, divide log of 16, right parentheses again, subtract 9, right parentheses, divide, left parentheses, negative 2, right parentheses, enter, and we get that r is about 4.698, and we need to round to the nearest to 10,000, so that means 4 places, 6, 9, 8, 1. Alrighty, let's go on. Alright, solve each equation. Notice, these are the easy ones, kind of. The logs and the bases are the same. We can ignore them, and we can say 9a plus 3 is equal to a squared plus 11. Ooh, the a squared, that means it's a quadratic. We need to get everything to the quadratic side and zero out this side. So a squared, we're going to subtract 9a. We're going to have to subtract 3, which equals plus 8. 0 equals factors of 8 that add up to negative 9. Well, that's just going to be negative 8 and negative 1. So a is equal to 8 and a is equal to 1. And then you could substitute it back in and try it out for yourself. All right, now we have another one. There's not a log on both sides, so we're going to have to simplify everything. So I'm going to add a 10 to kind of speed things up a little bit. Then we have a negative 5 log of base 7, 6x minus 8 is equal, negative 30 plus 10 is negative 20. Negative 5 is attached by multiplication. Divide both sides. Now we have log of base 7, 6x subtract 8 is equal to 4. Now the undoing of a logarithmic is exponential. So if its log of base n of a is equal to the exponent that we call n, when you rewrite it, it's b to the n is equal to a. So here's our b, here's our n, here, this whole thing is our a. 6x minus 8, we're going to add 8 to both sides. So 7 to the 4th is 2149 or something. 7 to the 4th. Oh, 2401. We're adding 8. So that's 2409 is equal to 6x. We're going to divide both sides by 6. X is equal, this is going to be about 400.167, so I'm going to put 16 repeating. All right, is that it? Yep, that is it for this week for videos.